Sawadee Krap. I know I'm basically holding you between a massive traffic jam and leaving the building, so I'm going to make this presentation fairly quick. What I'll do is I'll start with a background on DNVGL and then get into some of the issues that we see globally that countries need to look at when they are implementing EVs. Okay. Now, without a further ado, for those of you who don't know what or who DNVGL is, we are basically a technical advisory company. Some of you might know of Kima Labs, Kima Testing Services. We acquired Kima in 2013. So all the technical capabilities of Kima are DNVGL. Garad Hassan is another very big company in wind and solar technical advisory, which we also acquired. Okay, so when you hear Kima, it's DNVGL, it's the same thing. We have 4 business lines: maritime, oil and gas, energy advisory, testing services, and assurance. What I'll do is I'll focus more on the energy side. Most of our clients, when they hire us, and the reason we're in this space is because there's basically a increasing demand for energy, okay? Because of that, there's an emergence of energy markets, trading systems, trading platforms, cross-border trading, and there's also an impact on climate change and extreme weather. All right, so all of these things impact energy. We're growing as a world, as a planet, and we need more energy. So how do we do all of this in a more cleaner, more sustainable fashion without wiping ourselves out in the equation? Right, so our technical capabilities basically focus a lot around supporting a cleaner, smarter, and safer way of integrating energy into our lives and economies. And we do that through a series of areas covering the whole value chain of energy. What you see up there basically is the value chain that I'm alluding to. So we cover from policy, advisory, to production of energy and generation, transmission, distribution, and then to energy efficiency as well. Some of the areas that we cover are like your power testing and all under Kima. We do a lot of renewable energy advisory work. We do renewable energy certifications, transmission, distribution, asset management, energy storage, smart systems, and basically future-proofing utilities, future-proofing energy technologies to be able to contend with disruptive change in energy systems, okay? Now that brings me to the EV part, all right? I'm not going to talk about all the other things that we do, but what can DNVGL, for example, do in terms of looking at the reliability of implementing EV infrastructure in smart energy management systems for Thailand? I read early on today that about a year ago, March last year, there was an announcement that 200 EV buses was going to be launched, along with a whole bunch of other vehicles and things like that. And it's been 1 year. How much of that has actually happened? How many companies that are supplying EVs, or how many utilities, as well, out of the 3, how far have we gotten along as a country to be able to implement EVs, right? We've talked about energy storage, we've talked about batteries, we've talked about scaling up and should I say, scaling down of the price of electric vehicles. Now, the market is there, you know? The market is there, the technologies are there. How do we use all of that as a system and as a business model to create adoption of EVs into our daily lives? So when we look at that, we need to look at KPIs, right? A lot of the speakers today have been alluding to different parts of the value chain that we see. But what I'm going to try and look at now is how do you look at electric vehicles as part of a system of energy? You know, you cannot segregate it just based on energy storage or the type of vehicle or the smart charging infrastructure. You need to look at the whole solution as one, in totality. So you've got to look at safety, for example. Looking at the inverters, looking at the charging stations. How does that then impact reliability of the grid? Transmission distribution operators, in particular. If you've got massive amounts of electricity that is flowing out into charging stations, how does that impact your grid? You know, you've got industry consumers, you've got townships, you've got buildings, you've got traffic lights, you've got public transport. How does that work as a system? And all of that needs to be configured into a strategic plan across the government, the whole of government and industry. So then you start looking at operational efficiency. The customers, I think, Terence, you brought that up as well. How do you start looking at, where does your client, whether it's an industry partner that's going to absorb the energy for EV implementation, or is it, the entire population of Thailand that drives cars eventually? How does that have an impact on your utility? And then looking at the economics of implementation, right? What do you need as a grid operator to be able to augment your system to be smart enough to absorb and discharge energy across networks using electric vehicles, right? I was having a discussion earlier on today about this and looking at how we can how we can actually utilize energy, electric vehicles as grid storage, mobile grid storage, right? And that starts changing the dynamics of how utilities can look at investing in grid storage. Why should a utility invest in gigawatts of energy storage to try and combat variable renewable when you can potentially look at consumers buying electric vehicles and trading with your grid for storage, and for stability? So that comes underneath basically, looking at the regulations, looking at the market study, the energy market study, roadmap development, charging infrastructure, how that communicates with the utility, how that communicates with energy generators, whether they be variable or they be constant. Looking at the types of batteries that are being used, Not all vehicles will have the same kind of batteries. There's so many different types of families when you start looking at lithium ion. I can go on for one day about that. We can get a technical expert to train you. But the thing is, what kind of energy storage is interacting with your network? So you need to start looking at all of these issues. And then the impact of renewables, conventional generation, demand response, electric vehicle integration on your power systems. Is the power system smart enough to be able to manage all of that with high penetration of renewables and high penetration of electric vehicles in the next 5 to 10 years? And we as a company, we do a lot of energy storage testing and things like that. Now, what we're seeing is the trend, as mentioned by Terence earlier, the trend for solar is halving every year pretty much. We're looking at that same trend for energy storage at large scales, which means that in 5 years from now, energy storage plus renewables will actually become grid parity potentially, okay? Especially with these gigawatt type plants coming up. Thailand in itself is investing in a few very, very large energy storage plants as well. So the entire playing field is changing, and that's something that we need to consider, not as an individual manufacturer of a charging station or a battery supplier or an individual utility for transmission or distribution. You need to look at it in totality. And how do we work together, to basically develop a plan that effectively enables Thailand to take that step without crippling its economy, without crippling its energy systems, looking at financial performance, and the potential for growing that market, potentially even being a leader in the region. Now, I come from Singapore. We don't have many electric vehicles there, which is strange for an island, if you think about it. Cars don't travel more than 20, 30 kilometers, maybe 100 kilometers a day. But we don't have EVs. Why? Because we're not looking at a strategic approach across government, across economy, right? And I know there's a lot of initiatives happening in Thailand across different utilities, which is very encouraging, but there has to also be an integration of those initiatives across both the government and the private sector. So looking at a market study, what is the absorption rate of electric vehicles and storage as a solution within the grid? Looking at policy, regulation, the network impact that it has, the infrastructure that's required to future-proof, And then looking at these test beds, which are already starting. But are the test beds communicating with each other, for example? And if they are, how do you build systems of these test beds to be able to make them more commercially viable, right? So what I've got over here, I think it'll be circulated around, but basically this shows a process in which a country, a city, a state, a utility would take to be able to benefit from EVs integration, benefit from energy storage that will become sort of a captive source for demand response, for frequency regulation, for even energy trading. And how does a utility basically implement that? And that's about all I have for you today. So I hope I have not taken up too much of your time. And do feel free to contact us. We have an office here in Thailand, and we have about 200 people in the region focused on energy storage, renewables, and other things. And we look forward to working with you to be able to enable electric vehicle integration into Thailand's economy. Right? Thank you.